All right, think we're ready to roll. Hopefully my parabola will work well. I don't know. It needs to get a little bit further down. I need to cut the front out of it. Maybe not. Maybe the back. Who knows? Might not even work. Yeah, tennis ball. All right, we talked about square roots. What is somebody raise your hand, what's the index of a square root? What's the value of the index of a square root? Kyle. It is 2. Yes, be confident there. It is 2. What would you expect the index to be of a cube root, class? It is 3. That's what we're dealing with. So, number 1 here. What are cube roots? Well, as we just said, the index is 3. Adriana, can you close that door for me, please? So, cube roots, they give us an index of 3. All right, so let's apply the logic of what we understood roots to be. A square root was what number times itself 2 times equals the radicand, because the index was 2. Therefore, a cube root is going to be what number times itself 3 times. And how in the world did we ever know it's 3? How in the world could we ever figure out it's 3? I mean, how would we even know? It's just so hard, I know. But it is 3, right? What number times itself 3 times and equals the radicand? So that's cube roots. What number times itself, or what thing times itself 3 times equals the radicand? All right, so let's look at a couple here. So when you look at this and see the cube root of 8, again, I'm just doing that. I'm just circling that to focus your attention for me. So again, we're thinking what number times itself 3 times equals, and class, what's the radicand? 8, right? So that's the question. What number times itself 3 times is an 8? And if you know it, the answer is, what's the answer? 2. And why is 2 the answer? Because 2 times 2 times 2 is an 8. So what's the number that when you multiply it times itself 3 times gives you an 8? That number is 2. We took the complete root. Do we any longer have the root symbol? We don't, because we did the operation. We were able to take the root of the whole radicand, and therefore the root symbol is no longer there. Second example, we've got the cube root of 1,000. So again, we see a cube root. Because the index is 3, we say to ourselves, self, what number times itself 3 times? Equals what, class? 1,000, right? We're applying it to this problem. And therefore, if you know it, the answer is 10. Again, the y behind that, 10 times 10 times 10 equals our 1,000. So 10 times itself 3 times is 1,000. So the cube root of 1,000 is 10. Again, we were able to take the complete root of the whole radicand. Therefore, the root symbol is done. We've done what the operation told us to do. It told us to find what number times itself 3 times equals the radicand. We have done that. We no longer, therefore, have the root symbol. So that's when you're able to take the complete root. You're not always able to do that. In these, we were. All right, D. Cube roots. Any odd roots can have a negative radicand. You might say, Mr. Scarfy, why are you saying that? Because if you remember back to even roots, an index of 2, an index of 4, an index of 6, you cannot take an even root of a negative radicand. And the reason you can't is whenever you multiply 2 things together, the same thing, you can never get a negative result. Positive times positive is a positive. Negative times negative is a positive. Anything times itself 2 times or 4 times or 6 times always gives you a positive. So it's impossible to get a real number answer to an even index and a negative radicand. However, cube roots is different. So again, what's the question? We have the cube root of negative 8, right? What number times itself 3 times equals negative 8? Is there an answer to this? Somebody raise your hand. What's the answer? Josh? So Josh says negative 2 is the answer. And does it indeed work? Let's put it through the test. If it's the correct answer, we should be able to do negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is a positive 4. Positive 4 times a negative 2 is indeed a negative 8. So we can do an odd root of a negative radicand. And let me just be clear. Somebody tell me, what do I mean by odd roots? Give me some examples of odd roots. Somebody raise your hand. Give me some examples of odd roots. Jack? And what would 5 be? What do you mean 5? What is the 5? The radicand, the index, what is it? Index, right? An index of 5 is an odd root, right? Index of 3, 5, 7, 9, 11, right? That's what we're talking about. And this is the index. That's what we're talking about when we say an odd root. You have an odd index, all right? Not odd like some people are odd, but odd as in odd number, yeah. All right, so the cube root of any negative radicand is going to have to be negative. The cube root of any negative radicand is negative. Gotta be. Gotta be, gotta be, gotta be. All right, E. E, the cube root of positive radicands have to end up being positive. The cube root of positive radicands has to end up positive. And look, here's the logic. Just think about it. What's a cube root? What times itself 3 times, right? So the only way to end up positive is to have positive times positive times positive. That's a positive. The only other possibility is negative times negative times negative, and that gives you a negative. That's not a positive radicand. So for any odd root, if the radicand is negative, the final answer is going to be negative. For any odd root, 3, 5, 7, 9, 11, if the radicand is positive, the answer is going to be positive every time. Every time. Every time. Has to be. There's no other possibility. It's got to be. It's got to be. It's got to be. All right, number 2. Define cube roots. Just like we did in square roots, it's all about factoring the radicand. So factor the radicand. You know, when you guys were simplifying some of your roots yesterday, you were looking for numbers that are multiplied times themselves twice because you were doing square roots. Now we're looking for things multiplied times themselves 3 times because we're doing cube roots. All right, number 2. Take the cube root of factors that have 3. Oh, I wanted that to be green, so I'll just do it in green. Take the cube root of factors that have 3 of the same factor. That's what we're doing. To find cube roots, you simply take the cube root of factors that have 3 of the same factor. All right, so because that was at the bottom of the page, I rewrote it there so that we can think about it when we do our examples. All right? So all that is a rewrite of that same thing here at the top to make life easier on ourselves. All right, so let me leave that shown. All right, so here's the situation. You look at the cube root is 27. Now, how many of you already know the answer to cube root is 27? And some do. Okay, not everybody, though. Well, let's go ahead and factor the radicand. 27 is a 3 times 9. Agreed, right? And hey, 9's not prime, so let's keep going. A 9 is 3 times 3. Do you see how we have 3 times itself 3 times? Here's the question. What number times itself 3 times is a 3 times 3 times 3? The answer is 3. 3 times itself 3 times is a 3 times 3 times 3. Because it's a cube root, anytime you get 3 of the same thing, the cube root is that thing. So again, we're asking what times itself 3 times is that. So over here, cube root of 54, we're going to proceed the exact same way. We're going to factor. Anybody think 6 times 9 for 54? All right, let's go 6 times 9. You know your times tables. And of course, we know a 6 is a 2 times 3. By the way, you guys notice every time, right, since day one when I taught you guys how to do factor trees, I told you to cross off the factors once you use them. Hope you're doing that. It just helps be clear what you got left, and that's important. And again, you sloppy people and stuff, you end up getting stuff wrong because of these little details. What's a 9? We all know that's a 3 times 3. So look, here again, we got the 3 3s. Not the 3 Musketeers, but the 3 3s. All right. University of Virginia could have used 3 3s the other night. University of Maryland could have used 3 3s the other night, but oh well. I think they only had the cube root of it, right? What's the cube root of 3 times 3 times 3? It is 3. And what do you got left inside? You have a 2, right? There's a 2 left in. What's the only thing not crossed out? The 2. Now, I have to remind you, be careful here. Students forget to write the index. And it's a 3, and you got to show that. And what else is left underneath that 2? So we end up with 3 times the cube root of 2. And that's a simplified answer of the cube root of 54. That's similar to what you guys did last night with square roots, right? But only now we're looking for 3 of things because we're doing a cube root. So if you could do it last night with square roots, you should be able to do it tonight with cube roots. Let's do a couple more examples here. All right, so C here. Let's first off think about C. What kind of solution am I going to end up with? Negative. I'm just going to take care of that right off the bat. If I do it right now, I can just not even worry about it. Makes life a little easier. Just makes life a little easier because I know an odd root, cube root, 5th root, 7th root, 9th root, 11th root, 13th root of a negative radicand always gives me a negative result. I know that. Jordan, question? Okay. So I'm just going to put the negative out front already and get rid of it. Now I don't have to worry about it. So what would be the next step? What's the next step? By the way, Alex, I've got a couple papers for you from yesterday, so make sure you get those at the end. What would be the next step? What's the next thing I'm going to do? Come on, what's the next thing? Kaylin, what's the next thing? Factor the radicand. All right, go ahead. See what you guys can do with this. Go ahead and finish it off. Cube root of 72. All right, I'm going to pause the video. All right, here we go. Okay, so hopefully you said to yourself, I'm going to start factoring this thing. I don't know, 72. Who knows what you're thinking? I'm going 2 and 36. You can go a different way, right? There's more than one way to skin the cat. 36, I like 2s. I'm going 2 and 18. 18, I'm going 2 and 9. Now look, to be honest with you, I really never even bother to factor the 9. Why don't I bother to even take the time to factor 9, Raquel? Yeah, I won't get 3 of them. I know there's not going to be 3 of them. There's none of them already. Why am I going to waste my time to factor it? There won't be enough of them. I'm not going to waste my time. So, oh, look, I got 3 2s. What's the cube root of 2 times 2 times 2? It's a 2. Got my negative sitting out there for me, right? What's left? Don't forget your index. That would be a point off on a quiz, point off on a test. technically I can take them all off because a cube root's a cube root, not a square root. So don't forget your index. And what's left inside that niner? -2 times the cube root of 9. How many got it right? Okay. Now you got to be careful. It's not a square root. Because normally you see a 9, you think, oh, I can take the root of a 9. Well, you can take the square root of a 9, but you can't take the cube root of a 9, right? So you always got to be aware of what kind of roots you're dealing with. Okay, so that brings us to D. All right, we've done something like this before. Now remember, technically, let me review the rule for you. Everybody look at the screen. I'm going to do it here in the gap right here. Okay, everybody look at the screen. So let me review the rule for multiplying. The square root of A times the square root of B equals the square root of AB. So the cube root of A times the cube root of B will equal the cube root of AB. Now, we said when we were multiplying, we can either do the simplifying here, or because we know this and this both are going to end up under the radicand, we can do the simplifying right here. And that's the wiser choice. It's a little bit of a time saver. Because their two are multiplied together, if we can find a total of 3 between the two of them, we can take the cube root. So that's what we're going to do. All right, so let me get rid of this. So again, if you feel like you're more confident putting them together underneath 1, whatever you do, though, do not multiply the 20 times the 22. Somebody punch it out in your calculator. What's 20 times 22? 440. So this is what some students that aren't paying attention to detail do. So now they're at the cube root of 440. And what do they have to do to simplify this? They have to unmultiply. What did they just do to get the 440? Multiplied. Is that smart? That's not smart. You just wasted time. Now you got to undo what you just did. It's foolish. Don't do that. Right off of here, let's factor it. Again, 20, I don't know. Maybe you think 4 and 5. Maybe you think 2 and 10. It doesn't matter. But I'm going to take that 4 to a 2 times 2. Okay. That first one had 2 2s and 1 5. Let's deal with our 22. Hey, there's only one possibility there. 2 times 11, right? But again, look what we've got between the two of them. 1, 2, 3. Aha! With that signature sneeze at the end. So what's the cube root of 2 times 2 times 2? 2. 2's out, right? We don't have enough to get anything else out. So we have a cube root. Don't forget the index. And somebody raise your hand and tell me what the radicand is. Gabe? 55, because Gabe said the 5 times the 11 is a 55. Remember, we're multiplying, right? 5 times 11 is 55. So we got a 2 out for the 3 2's. What's left in? A 5 times 11. 5 times 11, 55. 2 times the cube root of 55. That's an exact answer, and we like exact answers. All right, let's look at E. Let's look at E. All right, E's a compound problem. Is E like the previous problem? No. The previous one we were multiplying, and this one we are technically adding, right? Do you add the same way you multiply? No. So be careful. So what do we want to do first? Somebody raise your hand and tell me, what should we do right now? Ashton. We're going to factor because we're going to try to... Why would we factor? We're going to try to simplify, right? All right. Factor the 24. See if you can simplify that one. Factor the 3 grand and see if you can simplify that one. Give you a minute. I'm going to pause the video. All right, hey guys, for time's sake, let me get back for a minute. Let me show you a little bit of a time saver. There's a lot of ways you can factor. What if I went, what if I went 3 times 8? Okay, would you agree that's 24? Didn't we already figure out what the cube root of 8 was? The cube root of 8 is 2. So instead of going all the way down to 2 times 2 times 2, I can just take the cube root of 8 because I know it's a 2. Be careful, we got this negative sign in between, right? And look, I'm going to do the same thing here. Didn't we already figure out the cube root of 1,000? What is it? 10. So I'll just do it right there. What do we have left? The cube root of 3, right? Can we finish this by adding them up? We can, because they are like radicals. What are like radicals? They have the same index. They have the same radicand. 2 positives of them and 10 negatives of them is 8 negatives of, what are the thems? Cube roots of 3. How many got negative 8 times the cube root of 3? Good job. Good job. What happened with the rest of you? Were you not quite there? Did I go a little too fast for you? Okay. All right. Hopefully you were heading in that direction, though, and that's where you were going. And remember, always look at the end to see if you can add. Sometimes you won't be able to. Sometimes you can. It depends on the problem. All right. Let's get to the last page. We learned this with square roots already. The inverse of a cube root is a cube. The inverse of a cube root is a cube. What is it? It's the base times itself 3 times. The cube root, the inverse of a cube root is a cube. And you guys should already know what cubes are, right? So here we have a 5 cubed. That's not a cube root, it's the inverse of it. And it's the base times itself 3 times, right? We're doing the opposite operation of taking a root. So you just take your calculator out and you'd multiply. Now, if I ask you to expand it, that's what 5 times 5 times 5 is. It's expanded. But if we want the value, we're going to take our calculator, we're going to do 5 cubed, right? 5 times 5 times 5, and the answer is 125, right? That'd be the value. All right, well, when cubing, cubes any odd exponent of, go to red, negative bases. Negative bases. Okay, let me pause for a second and translate that. Remember, the base is what the exponent applies to. So on our example here, we have a negative 3 base. And notice we have an odd exponent, an exponent of 3. An exponent of 5 would be an odd exponent. An exponent of 7 would be an odd exponent. Okay, so any odd exponent of negative bases are always, just like radicals, just like cube roots, negative. All right, so look on your sheet here. This, because it's a odd exponent, is the exact same thing as that. So we're going to do both. All right? On the first one, take your red. It's a negative. And then take your blue and do 3 times 3 times 3. That's what the first one says to do. You got a negative out in front, then a 3 times 3 times 3. What does that give you? What's the value? Somebody raise your hand and tell me. What's the value of negative, then 3 times 3 times 3? Negative 27. I agree. Notice it's negative. Let's do it the other way. Now the base is a negative 3, so we're doing negative 3 times negative 3 times negative 3. Negative 3 times negative 3 is positive 9. Positive times negative 3 is, look at that, we ended up in the exact same spot. Negative 27. Now that only works when the exponent is an odd exponent, a 3, a 5, a 7, a 9, etc. It would not work for a square root. And we went over that when we did square roots. They give you different answers. One's positive, the other's negative. Okay? So be careful. But in cube roots, it doesn't matter. All right, so here again, that same concept with our squares. Squares, any even exponent, are determined by whether the negative is part of the base or not. So look what happens with our two examples here. What determines it is whether the negative is part of the base or not. So let's follow the exact same protocol. The first example is a negative, and then take your blue and do the base times itself twice, 3 times 3. Final answer to the first example. Say it if you know it. Negative 9, correct. Now notice the difference of the second one. The base times itself twice. So we have a negative 3 times a negative 3. Final answer on the second one. 9. They are different. You got to be careful about that. You say, how do I know the difference? That's why we put the parentheses there. So you'd know. This will come into play when you punch it in your calculator as well. And this is something that if you learn early on will save you some trouble down the road when we get to Algebra 2. All right, not a big deal, but it is there. By the way, let me just remind you of some things. 1 cubed is 1. I'm just showing you the perfect cubes. 2 cubed is 8. 2 times 2 times 2. 3 cubed is 27. 3 times 3 times 3. 4 cubed is 64. 4 times 4 times 4. 5 cubed is 125. 5 times 5 times 5. You wouldn't know these. I figured them out. I didn't know them either, not all of them. 6 cubed, 6 times 6 times 6, 216. By the way, you don't have to memorize them. You're going to use them, that's all. 7 cubed, 7 times 7 times 7 is 343. And the last one I did, 8 cubed, 8 times 8 times 8 is 512. So one last question. Sometimes I'll ask you something like this. What two integers is the cube root of 75 between? What two integers is the cube root of 75 between? Well, here's what you do. 75 is between the 64 and the 125, isn't it? So watch. Here's the reality. The cube root of 64 is the 4. The cube root of the 125 is the 5. Therefore, what two integers does the cube root of 75 have to be between? 4 and 5. Now, I'll give you a hint, though. If you know how to use your calculator, if you punch in the cube root of 75, you know what your calculator say? 4 point something. What two integers is 4 point something between? 4 and 5. What if your calculator said 11.8? The two integers would be 11 and 8. What if your calculator said 17.7? Would be between 17 and 18. So if you know how to use your calculator and you know how to take the cube root, just punch it in. All right, my time's gone. Hey, I did reduce a little bit of the homework here. So I got rid of 36. Actually, I got rid of 35. Got rid of 34 and got rid of 37. All right, trying to streamline a little bit. Hopefully that still leaves you enough to get the concepts. Don't forget, quiz 11B mañana. Quiz 11B mañana. Ciao.